To solve this data sufficiency question, we'll consider each statement separately first, then together if needed. Before the statements, we need to determine whether we can find a value for the area of A, rectangle A, divided by the area of rectangle B. So let's just drop that down over here. So we're looking for whether we can find a value of area A over area B. This would give us the ratio of the areas, area of A to area of B. If we can determine that rectangles A and B are similar, then the ratio of their areas is the square of the ratio of the corresponding single dimensions, such as, let's say, the two given diagonals. So we would have the area of A over the area of B would equal 10 over 20 squared, which would simplify to a half, and if we square that, we would end up with a fourth. So in order for two rectangles to be similar, their sides must be in the same ratio. So we're interested in finding whether two rectangle A similar to rectangle B. So if area A is similar to, or if rectangle A is similar to rectangle B, we would have this relationship. So when we go through and look at the statements individually, if we're able to tell that the two rectangles are similar, then we can conclude that we would be able to find a value for the ratio of areas. So let's go ahead and let's start with statement 1. Since the ratio of length to width for each triangle is equal, so we have ratio of length to width is the same for both rectangles, that means that rectangle A and B are actually similar. And we said if we could show that rectangle A is similar to rectangle B, then we would be able to conclude this relationship of their ratios of areas. So that means that this statement is actually sufficient. We were able to show that. We don't actually need to go through and calculate it, but with the information that we're given, we were actually able to. And this is all provided that these two rectangles are similar. So we show that they are similar with statement 1, meaning that we can eliminate answer choices B, C, and E, leaving us with answer choice A or D. And to be able to tell if which one it's going to be, we're going to have to consider statement 2 alone. So let's go ahead and let's clear statement 1, and we'll start over and we'll look at statement 2. And again, if we're looking for whether we can show if rectangle A is similar to B. For statement 2, we're told that the width of rectangle B is 100% longer than the width of rectangle A. So let's just draw a quick small rectangles, and we can give widths to their names. Let's call this rectangle A and this one rectangle B. And let's give a width to rectangle A. Let's call it W, capital W. And it's 100% longer than the width of rectangle A. So let's call width of rectangle A little w. So from this statement, we can actually derive the equation capital W is equal to 2 times lowercase w. Because it's 100% longer than this one, so it's twice its length. Thus, the ratios of the widths are W, little w, over capital W, which would equal 1 over 2. This is the same ratio of the diagonals. Before we said the diagonals would be the ratio of 10 over 2, or 10 over 20, which would be 1/2. And these are for the diagonals. meaning that the lengths will be in the same ratio as well. If the widths are in the same ratio, so remember these are the widths, and the diagonals are in the same ratio, it implies that the lengths will also be in the same ratio. Now, if the widths are in the same ratio and the lengths are in the same ratio, and so are the diagonals, that means that everything is kind of scaled to each other. So rectangle A is similar to rectangle B here. So these guys would actually be similar. And we said before, if they're similar, then we can prove that this ratio holds, and we can find the ratio of their areas. So this statement alone is also sufficient. We can actually eliminate answer choice A, and our final answer choice would be answer choice D. Each statement alone is sufficient.